Okay, so the quiz is going to look very much like what you see here. So after we do it together, the best way to study math is to do math. Do it again. Can you repeat the process? If you can't repeat the process, you're not ready. Now, I have posted all of the 2-1 and 2-2 videos, so you're welcome to go back and look at those to get ready for the quiz as well. Okay, so feel free to write on regular paper, graph paper, combination of the two. You'll take pictures of those, but I want you to take them with you to study. Okay, so at this time, let's take a look at problem number 1. It says, which of the following are functions? Well, remember, if it gives you a discrete set like this, so we have that list of points, all you are concerned about is the x values and do they repeat or not. So in number 1a, the x value of 1 repeats itself with a different y value, so this would be a no. And it's all because of these ones right here. So the x's are not allowed to repeat, so that would be a note you could make to yourself and a fact you want to have memorized. But if we take a look at B and we look at all of the x values there, every single x value is different. It doesn't matter that the y values repeat. They can repeat as many times as they want, so this is a yes. Now, if we take a look at 1C, any vertical line that I draw, I'm sorry, that's not completely vertical, but you know what I mean. Any vertical line that I draw is only ever going to hit it once. So that means the x's have only been paired up once. So that's a yes. This one here is a no, because you can see I can find many different vertical lines I draw would hit it twice. This one is actually a function of x. This one is not. It's a function of y. It's a funky one. It's when it lays on its side like that. Okay? Do we have any questions about identifying whether or not something's a function? Good to go? Okay. Now let's practice plugging into a function. So now let's look at 2. Now let's look at what we've got here. We've got this function of x that anytime we plug in an x, we're going to have to do whatever we plug in. We're going to square it first, following order of operations. Then we will multiply by 2. Then we will subtract whatever -5 times that x value is. So this is your input. That 2x squared minus 5x is your output. Okay, so let's plug in a. The great thing about doing something like that is all you're doing is the x becomes an a. That's it. So don't overthink that. That's going to be 2a squared minus 5a. Nothing else to do. Okay? It's just a swap. The x's get swapped out for an a. That's it. Don't overthink it. You guys are smart. You tend to sometimes overthink things. It is that simple. Stop. Don't go further, because we don't know what a is. If a had a numerical value, we'd plug it in. Okay? Let's look at this one. Now here we're going to have to follow order of operations. I like input in with parentheses. That's very helpful. So if you do 2 times that value squared minus 5 times that value, you just got to think of how would I do it following my order of operation rules. What's the first thing we have to do?
Exponent.
Yeah, we got to do that exponent right here, right? We got to do that square. So that would be 2 times 4 minus 5 times 2. What's our next mathematical operation we got to do? Got to do those multiplications. So we get 8 minus 10 for a value of -2. Okay? If you tell me on the quiz that that is the point to -2, I'll give you a bonus. Okay? So if you show me that pair relationship, that ordered pair, I will give you a bonus. Okay? Let's take a look at C, -1. If you plug in a positive like we did in B, you don't have to use the parenthesis notation. It's helpful, but for C, definitely use that notation. So put that input of -1 in parentheses, okay? That's a very helpful thing to get used to, okay? So again, if you think about the order of operations, it's still going to happen the same way. We have to do that exponent. Then we're going to still have some multiplication to do before we go further. Now let's think about the fact that -1 is in the parenthesis. So that really means a -1 times a -1, which is two negatives multiply together and give you a positive value. So that's going to be 2 times 1 minus 5 times negative 1. Now we still have some multiplications to do. 2 times 1, yeah, that's just 2. Watch this back piece, that negative in parentheses. Some of you didn't use parenthesis notation, and you tried to subtract where you should have multiplied. So be careful with that. Negative 5 times negative 1 is positive 5. So just change that to a plus between them. You're still adding or subtracting, but now it just flipped to a positive. Our answer is 7. If you tell me that's the order pair, negative 1, 7, good to go. Okay. Do we have any questions about 2, A, B, or C? Now, the most difficult one is D, okay, but let's take a look at it. So you're going to get partial credit if you just take out the x and replace it with x minus 1. Okay, so that's what it looks like on its initial placement into the function. So that's the initial input. So if you get it there, you're going to get partial credit for doing that part correct. But I want it simplified as much as possible. So let's talk about that. You need to do this piece as x minus 1 times x minus 1. Do that exponent first. Okay. Now let's explore what is x minus 1 times x minus 1. So you're thinking about that. Okay. Well, x minus 1 times x minus 1, I'll do it right here. We're going to distribute. So we're going to take the x, we're going to multiply it twice. X times x is really an x to the first times an x to the first. So you keep the x, add those exponents, so that's going to be x squared. Negative 1 times x, negative x. Negative 1 times x, negative x. Negative 1 times negative 1 is positive 1. You should get that big, long string of 4 things, and then you'll have to combine some junk. Okay. Does anybody see the like terms that we can combine? What are like terms we can mush together? Yeah, those negative x and negative x. So we have 2 of those. They are both negative, so we get negative 2x plus 1. So let's put that back up here. That's x squared minus 2x plus 1. Okay. So everybody take a minute, make sure you understand how to do that. And if you have any questions, let me know. There will be one like that. We're not done yet, but I want to make sure you understand this phase before we go to the next step. Any questions about how we did that multiplication? Okay, you got to distribute. Some Algebra 1 teachers call it FOIL, however you want to think about it, same idea. Okay, now, from there, so I'm going to put this up here. Okay, so from there, if it lets me. He doesn't want to. Anyway, I'll deal with that later. So now let's think about what comes next. This 2 needs distributed into its parenthesis. Negative 5. Remember that negative in front? It has to distribute as well. So it has to distribute into its parenthesis. So let's do that. We get 2x squared minus 4x plus 2. That's the first one. Okay, now let me show you how I did that. 2x squared times x. 2 times x squared. 2 times negative 2x. 2 times 1. That's this. Now I'm going to distribute the negative 5. So we're going to do negative 5 times x. Negative 5 times negative 1 is going to give us negative 5x plus 5. See how that last piece turned into a positive? Everybody good with how we got to that? That makes sense? Okay. Are we done? No. Are there like terms? That's what you look for, okay? So I usually go highest power to lowest. You don't have to. It's helpful to keep that order because for things we're doing on later on. So let's start. We got a 2x squared. That's our highest power. What could we combine negative 4x with? Yeah, that negative 4x and that negative 5x are like terms. Just combine those coefficients. Negative 4 plus negative 5 is negative 9. Just keep that x along for the ride. What could we combine our positive 2 with? We can combine that with that positive 5. And so that's positive 7. And that's your final answer. That is as far as you have to go. So quite a few different steps that you would take for that one. It just doesn't want to move. Let's go there. Okay. Any questions at all about plugging into a function or how we got that first part? Any questions at all about plugging into that function? Good? Okay. Now, the next section, section 3, asks which of these are linear. So let me give you kind of something you can study a little bit on the side here. Linear equations will either be able to put into y equals mx plus b. That's one way you'll see them. You'll see them in standard form, ax plus by equals c, where the a, b, c are just real numbers of some sort. It could be y equals a number. It could be x equals a number. So those are the most common types. Let's look what they have in common. There are no powers allowed on the x's and y's. The x's and y's can't multiply together. They're separated by pluses or minuses. That's really a good way to think about what makes something linear. So no powers. X's and y's can't be in a denominator. They're just x, y. X plus y equals a number, okay? So if we think about this is what we're looking for, now let's go over and find which ones are like that. Do we see any right off the bat that have a power on the x or the y? Any of them on there have a power on the x or the y? Any of them have a power on the x or the y? A, B, C, D, or E? Which one has a power on it? B. So we know that one is no. It's not linear. Because it has a power on it, okay? These two are in standard form. Now, D, it's not great. It has that half there instead of a whole number there, but it's still okay. These are linear. This one, although it doesn't look like it, this one is in slope-intercept form. That f of x is exchangeable with a y. It doesn't matter. You can take that out and make it a y. This one's linear. And then our other one, y equals 5, is by definition a horizontal line. So it's linear, okay? So things that don't make it linear, powers, if you have like 1 over y or 1 over x, wouldn't be linear, okay? So all those are linear actually except for b, okay? So just make sure you know this rule here, that linear functions, the x's and y's are separated, no powers are allowed, you can't have x's and y's in the denominator, okay? Everybody good with 3? So that's a rule you can kind of put into your head. Now let's talk about intercepts. So on the quiz, you'll be asked to find the x and y intercepts. Let me remind you how to do it, okay? To find the x and y intercepts, I would suggest making that 0, 0 chart that we did in the homework. In one of the notes we took and one of the homework, I suggested that. This here is going to be our y-intercept. This here is our x-intercept, okay? So if you make the 0, 0 chart, that is all you need. It will answer both of those things, okay? And I'll show you how to kind of finalize your answer as you go. So let's do our first one here. Let's do A. X minus y equals 7. Okay. So what we're going to do is we're going to make a little chart to the side. We're going to put a 0 for x. We're going to put a 0 for y. Now, if we let the first one here is our y-intercept, you'll notice we're letting x equal 0. So we're going to take out the x, and we're going to replace it with 0. Now, when we replace it with 0, it's really not there. It's not there. If you add 0 to anything, it's just that thing. So you don't have to show this part. If you just jump right to the negative y equals 7, go for it. How could we get that y to just say y equals? How could we get rid of that negative? How could we get rid of the negative that's on front here? Yeah, you can divide off that negative. If we divide by negative 1, What is 7 divided by negative 1?
Negative 7.
Negative 7. So it becomes negative 7. So put it in there. Now here's what you have to do to prove to me that it's the y-intercept, okay? All I need you to do is say 0, negative 7, and put a little y-intercept next to it. But that first value on the 0, 0 chart, that's it, okay? Now let's do the second one. Let's do this one, okay? This time, y is equal to 0. So if we look at our value here, x minus y equals 7, would be x minus 0 equals 7. What's x minus 0? What's x minus 0? Yeah, that's gone, right? If you subtract 0, it doesn't change it. So it's just going to be x equals 7. We're done. We didn't have to do any math with that. That one was really nice. So let's throw it on the chart. That's our x-intercept. So when they ask for intercepts, that 0, 0 chart is going to point you in the right direction. The y-intercept, you're going to let x equal 0. The x-intercept, you're going to let y equal 0. And then you just solve. Now, when it's in standard form like A, that's the easiest one, I think, to find the x and y intercept. But let's talk about if it's B. Okay, so let's do it again. Any questions before I go on from A? Do we have any questions about A before I jump from that to B? Any questions there? Okay, let's write down B. Y equals 2x plus 4. And let's put our little 0, 0 chart on the side. If we fill that out, we're going to answer the question, okay? So the first one here, our y-intercept, we're letting x equal 0. So we're going to take out the x. We're going to put 0. So it's really going to be y equals 2 times 0 plus 4. What's 2 times 0?
0.
Yeah, we know the y-intercept should be that value on the end. Remember, y equals mx plus b? The b is our y-intercept, so it should make sense that that's that. So now we can say that 0, 4 is the y-intercept. Okay? That's where the graph hits the y-axis. The one that's harder, when it's in this form, is our x-intercept. It's just a little harder. Okay? All we're going to do for this one, we're going to let this be 0. Okay? So we're going to let that be 0. So it's going to be 0 equals 2x plus 4. Do you see how we just have a little more math to do? But it's not a hard equation to solve. What do you want to do to get that x by itself? What do you think we can do? There's lots of ways to approach it. What do you think? What do you want to do? Natalie, you got an idea? What could we do to get that x by itself? Yeah, so move that 4. Now, some people might move the 2x. That's great. Some people might move the 4. That's great. Doesn't matter. If we subtract 4, we're going to get negative 4 equals 2x. See how that 4 moved to the other side and changed signs? That's good. Now, how do we get rid of that coefficient that's sitting on our x? Got to divide it off. We're going to divide by 2. We get negative 2 is our x-intercept. So although the y-intercept is just staring at us right in the face, it's that 4. For this one, the x-intercept, you got to do a little bit more work. So that's, it's great. We see the slope and y-intercept. The slope is 2, the y-intercept is 4. So you don't have to do much math. I don't need to see the chart for the y-intercept. It is 4. It's all right there. But if you make the chart, that's going to help guide you for the other one, okay? Anybody have any questions about B? Okay. Now let's do C. One last one. First thing you want to do is rewrite this as y equals x plus 3. F of x is just a fancy way to put a line in a function notation. So just take off the f of x, pretend like it wasn't even there, make it a y, and make that chart again. What do we know the y-intercept is? Just by looking at this one. 3. So if you just want to put a 3 there and do no math at all, I'm okay with that. I want you to be able to recognize that and go, it's 3, okay? The one that we have to do some math for is the x-intercept. It's harder. And it's even harder when we do higher level equations like quadratics and other ones. It's just harder. It just is. But you're still going to make y equal to 0. Now this one's great. Because there's no coefficient on the x, we just move the 3 and we got it. If we move the 3, what does it become on the other side? Negative 3. So now we know the y-intercept. So all you need to do for me is just kind of summarize what you found. 0, 3 is the y-intercept. Negative 3, 0 is the x-intercept. That's all you got to do. Okay? So there will be 1 or 2 that are in standard form, 1 or 2 that are in slope-intercept form. Okay. Do we have any questions about how we go about finding the intercepts? Any questions at all about that section of things? You guys good with number 4? Okay. Let's go to 5. The last thing that's going to be on the test is to graph some lines. So that's the last, or the quiz. The last thing on the quiz, graphing some lines. So let's take a moment and graph some of these lines. Now everybody, let's just summarize for a minute before we jump in. This one, 5A. You want to make a 0, 0 chart. Find those intercepts. That's the easiest way to do that. B, you want to use slope-intercept form. C, you want to use slope-intercept form. D is a special kind of line. We'll get back to that in a minute. E is a special kind of line. We'll get back to it in a minute, okay? So knowing your strategy is helpful. So we're going to use y equals mx plus b for this one. We're going to use y equals mx plus b for this one. This one, those last 2 are special ones. We'll get to that in a minute, okay? So first, guys, let's graph A. So here, if you haven't used your graph paper yet, there you go. Okay, but let's make yourself a little grid, or make yourself, your XY axis for me. Make our XY axis. Okay. Let's talk about 5A's 0, 0 chart. Okay. If I make the x0, think about the fact that we wouldn't see the x anymore because it's now 0. We're going to get negative y equals 3. So if negative y is equal to 3, or the opposite of y is equal to 3, what's y equal to? Negative 3, right? See how it flips that sign? Okay. And then now we're going to let y equal 0. And that's great. It just gives us x is equal to 3. And so go over to your graph paper. Find the point 0, negative 3. That is our y-intercept. Find the point 3, 0. That is our x-intercept. Connect them. Stretch it, please, across your graph paper. Don't be lazy. You can have a ruler tomorrow. Stretch it out. And make, because you want to show that it's really stretching across your graph paper. Okay? So this is the point 0, negative 3. I put on the point 3, 0. Connected. Got my line. Everybody good with that one there with A? Okay. Let's talk about B. Y equals 2x minus 1. Okay, so the first thing I want you to do, if you could make yourself a little grid, your XY axis grid. Okay. What is the slope of this line?
2.
It's that 2 that's on the x, so your coefficient on the x, okay? So you're going to pull this value off. So if you don't see it, it's a 1. Otherwise, use the number there. How could we write that so we see the rise and the run? How could we write that so we see a rise and a run, so we see 2 numbers? So it looks like a fraction. What could we do? Yeah, put a 1 underneath it, right? That's all we got to do. So that means we're going to go up 2 and over 1. But we need a starting spot. That is our y-intercept. What's our b? What's our y-intercept?
1.
Yeah. Make sure to include the negative with it. that -1 is important. So we're going to start at the point -0, -1. So remember what you do. Start at the y-intercept. The slope tells me how to move to the next point. Okay, so go to the y-intercept of 0, -1. Put your dot. We're going to count up 2 over 1. Up 2 over 1. It should be going up to the right since our slope is positive. So up 2 over 1. And I was never good, and I still am not, at making my line real straight. I think my hand's a little shaky. So I always put a few dots there to really kind of guide me. And please put arrows on the end. Stretch it across your graph paper. Okay, so remember what we did. We started at the point 0, -1, our y-intercept. Then we counted up 2 over 1, up 2 over 1, up 2 over 1, as many times as you want. You only need 2, especially if you're using a ruler. So tomorrow when you take your quiz, getting a ruler is probably a good idea. Do we have any questions how we graph B? Everybody good with that? Okay, let's do C. C, although it says f of x equals x plus 2, think of that as y equals x plus 2. F of x equals x plus 2 is the same as y equals x plus 2. It is just function notation replacing the y value. What is our slope? 1, right? If you don't see that coefficient on x, we've got one of them. Our slope is 1. We need to do 1 over 1. What's our y-intercept? 2, so that's the point 0, 2. So let's make our grid. Where do we start? What point do we start at? 0, 2. We know we hit the y-axis at 2. That's our y-intercept. Put the dot down. So that's your starting location, okay? Now our slope is positive 1. So for every 1 we go up, 1 we go over. So you would just go up 1 and over 1. And there you go. Make your line, stretch across your graph paper. Everybody good with that one? Now, D and E, you have to know the rules, okay? Now, obviously, you can make a chart. There's some information you can still use y equals mx plus b kind of on D. If you think about it as y equals 0, x minus 4, your slope is 0. That does work. So you're okay you doing that. But all you really have to memorize is this is horizontal and this is vertical. Y equals a number is horizontal, x equals a number is vertical. You have to memorize that before tomorrow. Y equals a number is horizontal, x equals a number is vertical. Okay, let's go to D. Let's draw that on our paper. So it's y equals -4. Okay, so make your XY grid. And what sometimes I'll do, you can think about it as your y-intercept. I go down to -4, I put a dot. Well, y is always -4, and so over here it's -4, over here it's -4, over here it's -4. However you want to think about it, it is stuck at -4. Okay? So a y equals a number is always going to be horizontal line. Okay? The last graph we're going to do is of a vertical line, x equals 2. So x equals a number is vertical. So make your little grid. The way you can kind of remember it is x is stuck at 2. X is stuck at 2. X is stuck at 2. The y can do whatever it wants. It can be 4 or 7, -2, -8, -6.2, I don't know. And then just make it vertical. Okay? So, this is what your quiz looks like. The best way to do math is, or the best way to study math is to do it. So try it again. Can you repeat the process? Okay? So turn this in at this time. Take the rest of the period if you want to make some notes to yourself, or if you want to try it again. Look back at any of our old note sheets. If you haven't turned something in, take a look. Make sure you've turned everything into Google Classroom. And there you go. Do we have any questions at all? Okay, you guys, there you go. Quiz tomorrow.